Hello, I'm Open's Heart. Welcome to episode 3 of my layman's series on climate. This episode will discuss the planetary climate range and energy. In episode 2, we laid out a possible planetary climate range. In this episode 3, we will review this range in terms of energy and water. Using energy and water, we will build a case for describing this subject in terms of energy. Here we have the range that we discussed in episode 2. It is a range of climate possibilities from a completely frozen planet at one end to the other end where a planet is so hot that liquid water cannot stay on the surface for long. It is the state of water that helps us quantify the changes over this range of possibilities. At the low end, water will be in a frozen or solid state. As we move up the scale, more water will phase shift to a liquid state. At the high end, water will phase shift to a vapor state. Now I'm going to do a bit of word dancing here, so hang with me. When we talk about water going from frozen to liquid to vapor, one normally thinks of that in terms of heat, but technically there is more to it. The phase shifts from ice to liquid or liquid water to steam register as an increase in energy, not an increase in temperature. If you look at the graph, the temperature of the ice rises until it reaches the freezing point. Then the temperature holds steady as the ice melts. The water molecules get excited or energized enough to phase shift from solid ice to liquid water. In this transition phase, the water molecules of liquid hold more energy than the remaining water molecules of ice, even as the temperature of both remain constant. Once the ice is melted, the temperature begins to climb again. So this starts to shift the story from being about increasing heat to increasing energy. Allow me to expand on this further by asking an off-topic question. Are microwaves hot? Are microwave ovens themselves hot? I would offer microwaves are not hot, but when you direct microwave energy into water, the water becomes hot. This leads me to draw out a nitpicky but important distinction. The story of water going from frozen to liquid to vapor is actually a story about energy, the amount of energy the water has. Low energy and the water will freeze. Medium energy and the water will melt into liquid. High energy and the water can be made to boil to steam. This can be applied to our planetary climate range. We can think of it in terms of energy. The energy required to keep a planet above freezing. The energy required to keep a planet green. The energy required to remove liquid water from the surface. Thus, the state of water is a marker or a symptom of how much energy a planet can hold. A frozen world indicates the planet does not hold much energy. A steamy world indicates the planet holds a lot of energy. I'm making a special purpose of describing this in terms of energy. One of the points of this series is to shift the discussion from warming or temperature to energy. Warming or heat is just one facet of energy. Temperature, especially air temperature, is only part of the story. Air temperature, or how warm a planet feels, is a secondary effect of the energy the planet is holding. To see the whole story, one has to look at the full expression of energy. As we go on in this series, we will build support for the idea that energy is a better framework for understanding this subject. I invite you all to stay tuned to episode 4, where we discuss this planetary climate range in terms of habitability.